Okay, I just want to go over some stuff with the lab in case you have any more questions. There are several parts to this. The first thing you have to do is watch the pre-lab video. Everything, if you looked on Schoology, these are all from just January 11th, CHS Pit Lab 2. That's where you can find all of this information at. So if you go to the pre-lab, the first pre-lab question asks you what the cations and anions are. When you're writing these, you have to put the charges down, the oxidation numbers. I can give you a hint that there's 2 cations and there's only 1 anion. And the anion might be large. And if you read in the reading of the report, it tells you exactly what the cations and anions are. Number 2, this is when you're actually doing the lab. You always have to make sure you have very clean equipment. For the flask, it mentions, and you can see her doing this, that she's rinsing it with deionized water. You have to make sure that there's no residue of any other solution in your flask. Do you need to dry it before use? No, because you're just putting water in it. You shouldn't have any water, like massive amounts of water in it. But if you dump the water out, you don't have to dry it with paper towel. The beaker, again, all equipment should be washed with deionized water all the time in the lab. You do have to dry this before use, though, because you're putting solid in it. And if you put too much solid, you might have to take some solid out. And if it's if it's dissolved in liquid, then you can't do that. The burette. The burette, you always have to rinse with the solution that you're putting in there. So you will see her rinsing the burette in the video. You have to rinse your burette, all the sides, wash all the sides of your burette down, and then drain it. You have to rinse it with the solution that you're putting in there. And you have to dry it. No, that would be impossible to dry the burette with paper towel or anything because it's so long and skinny. Part 3 said calculate item 2 on the lab report on page 10. That was actually right here. You're calculating that right there. Oops. Right here. So if you go to the lab report page, this is what they're talking about. Right here. All right, now I want to get to the lab report page because I don't think there's any more on the pre-lab page. What is going on here? There we go. I think that was all they wanted you to do for the pre-lab, so we're going to close that out. All right, so make sure when you are doing the pre-lab, you cannot just put an answer. They're not going to give you credit. You have to show the equation you're using. You know, you're using moles equals molarity times liters. Then you have to put the numbers you're using. You know, and you have to use units. So you know this is moles per liter and you know this is liters. Cross out your units. Make sure you do that. This is going to give you moles, but then they ask you to find the grams. Again, show your units. Show your work. This, you're adding all of this up from the periodic table. I would take it to 3 decimals. And remember, your units are grams per mole. And again, your mass. You know what, I think they may have it in 2 decimals in the lab. I think they'll accept 2 or 3 decimals. I don't know how, I can't remember what they used on the scale. Again, this will be 2 or 3 decimals for the mass once you're done. You have 3 sig figs here, so it just depends on your number. If you only need 3 sig figs, then it would only be 2 decimals in your grams. So this 3 sig figs would only be 2 decimals in your grams. All right, so that's easy. Number 3, the mass of the empty 50 milliliter beaker. She tells you that. You write down exactly what she tells you. And again, it's going to be grams. They're going to take a ton of points off if you don't have these units. She also tells you the mass of the beaker and the potassium ferrocyanide. How do you get the mass for number 5? It's also going to be grams. And I'm going to write 3 minus 3, but that doesn't make sense. All you have to do is subtract them. You're subtracting, can I put 4 here for you guys? So it's just 4 minus 3 equals 5. All right, so those were easy. That's pretty self-explanatory for you. The next part, your moles of potassium ferrocyanide. Anytime you see those little stars, that means you have to show your work. I would show my work for everything just to be certain you get points for everything. So this is what you got, number 5. And you don't write number 5. You put the number that you got in number 5. And that's going to be grams, and make sure you use your units. Right and crooked again. And this is what you got in number 1. And this will be moles. Again, watch those sig figs. You should be, I believe we're still at 3 sig figs in this problem. It might have went up to 4, number 5, but just watch them as you go. This concentration, again, show your work. Molarity equals moles over liter. Concentration is molarity. They tell you that you're making a 100 milliliter solution. You can actually see it. So you take your number 6 and divide it by your 0.1000 liters, which is 100 milliliters, changed to liters. And this is going to be your molarity, your concentration. Number 8, they give it to you. Number 9, this is from the reading. This is from the reading, or I believe she used a pipette. I believe she used a pipette. Oh, she did use a pipette. So she uses a certain volume of this solution you just made. I'm not going to tell you the answer to that. Number 10. So that's with the pipette. When she's going through this, she's explaining a lot of it to you. The only thing I had a problem with is she didn't show you the burettes to get your own readings, but that would have been difficult. The moles of potassium ferrocyanide, well, you know moles, and this is one you have to show work for, molarity times liters. So you have this in number 7, and that's going to be moles divided by liters, and your liters in number 9. Make sure you change it to liters. Your answer for number 9 was in milliliters. Make sure you change it to liters before you solve for this. Then your units for number 10 would just be moles. All right, your burette readings. She tells you what your burette readings are, so make sure you pay attention. All of these, right off the bat, I would go through and put milliliters, so you don't get docked any points for units. All right, they also, these are all 2 decimals. All of these are all 2 decimals. How do you get number 13? You take 12 minus 11 for each run. Trial 1, trial 2, trial 3. You take 12 minus 11. How do you know what you're starting with in your run 2 and run 3? Well, if you end with 21.51 milliliters in your burette, that's obviously what you're starting with for your trial 2. Okay? Now, she has to refill it here, so you have to pay attention after she refills it what she's starting with for trial 3. All right. Number 14, that was pretty easy. Number 13 is just watching her do the lab. It's a titration. She's adding her solvent, her zinc sulfate, until she gets like a pale purpley blue color. 13, the volume of zinc sulfate added, the average, or the 14. You take all your number 13s and you add them up and you divide by 3. And again, this is going to be in milliliters. Now, I'm going to go back in a second and tell you to write something else up here in addition to writing just the average, just from previous years. They've wanted this. All right, where is my stuff? My stuff. All right. The next thing is standard deviation. All right, so I'm going to show you how to calculate with your calculator. I think that's easier for you. I think they preferred it with the calculator. All right, just... All right, so I made up some fake data here for you. Say that our 3 volumes, and this is hypothetical, come out to these volumes from the titration experiment. To get the average, we add them all up and divide by 3. So this is our average volume of zinc sulfate. To get our standard deviation, you can do these different ways. The standard deviation is going to be represented by SX on your calculator, and the standard deviation of the mean is SX divided by the square root of how many trials you have, which in this case it's going to be 3. You can do this with an Excel spreadsheet. So what I'm going to do is put these 3 values just in an Excel spreadsheet right here. And then I don't even think I have to highlight them. I can go standard deviation dot S parentheses, what am I, C9, put in your cells to C11. Make sure I have all that typed right. You just put in this formula up here, press enter, and right there it tells me my standard deviation is 0.586. Okay? Now, if I needed, this is your standard deviation, that was easy for you to find. To get the standard deviation of the mean, you would just take 0.586 divided by 3, because that's all I had right there, and it came out to be 0.34. So what does that mean? What does that 0.34 mean? So if we go back to our lab report, back it up a little bit. So that 0.34 that we just calculated, that's more or less our average volume of zinc sulfate would technically be 19.5 milliliters, and you would only need this 1 decimal place plus or minus 0.3 milliliters. You would only want this uncertainty to 1 decimal place, 1 sig fig. That's the uncertainty of that volume. We can use the standard deviation of the mean to figure out our uncertainty. Okay, the standard deviation is just the average spread of the data around the mean. That's all it is. So we use the standard deviation, found the standard deviation of the mean. That's our uncertainty. Change the sig figs, so it would be 19.5 milliliters plus or minus 0.3 milliliters. All right, the next thing we would have to do, I want to show you. So it's not really letting me go to my webcam right now, so I'll pull it up at the end here, make another video. The average number of moles of zinc sulfate added, well, that would just be, use your equation, moles equals molarity times liters. Your molarity of your zinc sulfate, I believe, was your number 8. Make sure you use your units. And then your liters was your number 14. Now remember, your number 14 is in milliliters, so you have to convert it to liters when you find these moles. So that's going to be your moles.